Okay, so we're going to look at our second type of graph that we're going to do with our rational expressions. And if you'll notice, the only thing that I really changed here was I put a 2 there, where earlier we just had it as an x. So one of the things that is going to do is affect our asymptotes. Because again, when we look at what x cannot be here, hopefully you realize it can't be 2 or a negative 2 on there. So my asymptotes is x equals 2, x equals a negative 2, which means that I'm going to have 2 vertical asymptotes, not just 1. So that changes it by putting that square there. We now have 2 vertical asymptotes. Okay? Now, one of the things that it did not change was my horizontal asymptote, and it's still going to be at y equals 0. And we can talk about that and show you that as we continue. So we're going to go ahead, just like what we did before, and we're just going to make a quick t-table. Put some numbers in. So let's start in the center section there, and let's put in, well, I'm just going to start with 0. That'd be an easy one to do. So that would give me a negative 1/4 if I put 0 in. Hopefully everybody knows where I'm getting that. So that is 1 over 0 squared minus 4. So at 0, I'm at a negative 1/4. So about right there. Okay? And let's go ahead and put in a negative 1. So that would be a negative 1 squared minus 4 would be negative 1/3, which would be a little bit further down than the 1/4. I figured out my computer does not like me for some reason kind of holding it and touching like that. And then let's put in 1. And you're going to notice you're actually going to get the same thing. So we actually have that reflection. So this is very similar to our quadratics in the fact of the reflection piece of it. Okay? So there's what I have. Now, I could keep putting numbers in. Now, obviously, I can't put in 2, but I could put in like 1.5 if you wanted to try that. But hopefully you'll just kind of believe me when I say what's going to happen is it's going to just kind of come down through here. It's going to get closer and closer, but it's not going to cross. Okay, so it looks very similar to that of a parabola here, because that technically should come up a little higher. It's not flat there. I just can't get it to, there we go. So it's going to look like a parabola. Now, sometimes when you do these, they'll look like a parabola. They'll open up, down. Sometimes it actually looks like an x cube inside here. But that's what we have. Now, let's go ahead and look over on the other side. So let's do over and do 1, 2, let's do 3. Let's put a 3 in. So that would be 3 squared minus 4, which that would be 1 over 9 minus 4, which is 1/5. So at 3, I'm at 1/5. Okay? And okay, to put in a 4, 1 over 4 squared minus 4, which would be, whoops, minus 9, minus 4. So 4 squared would be 16 minus 4, that's 1/12. So that's really low. Okay? So you can see it's getting closer and closer. Now I could go back in and I could put, it's kind of a pain to do it, but I could put in 2.5. So 2.5 and put it in my calculator if I want to. I think I'm actually going to do it that way. So I'm going to put in 2.5 squared minus 4. I'm just going to put that piece in. And it's 2.25. So 1 over 2.25, which is about 0.4, it looks like. So we're going to have at 2.5, it's going to be about 0.4. So it's going to come up to here. Okay? Not sure what my computer, why my computer does. There we go. Anyway, so what we're going to end up seeing, guys, is it's going to come down through here. Okay, look like that. And then when you go over to the other side, again, since it is squared, it doesn't matter if I've got a negative or a positive, right? So it's going to put it up on the top. Okay, hopefully that makes sense to you. Whoops, sense here. See if I can do this without it. There we go. Okay. And again, that is because it doesn't matter if I put in the negative 3 when I square it down here, see if I put a -3, it's a -3 squared, it's still going to get me exactly the same answer. And there's what my graph looks like. That's kind of funky, isn't it? Okay, so again, if it was, that's -4. If it had been x squared minus 1, then everything would have just been kind of consolidated a little bit. Your asymptotes would have been at 1 and 1, 1 and -1. So that is your second type of graph when it has something similar to that in the denominator. Now, they don't have to always be exactly the same. We could definitely put it as just a real quick y equals, let's do 1 over, let's do x squared plus 2x minus 3, okay? So the key here is you're going to have to factor, and hopefully you see that that's plus 3 and minus 1, factors of a -3. So in this case, my asymptote is going to give me -3 and 1, okay? So when I go to draw, my asymptotes are going to be, again, at 1 and a -3. And then I'm still going to have this one at 0, okay? And then you could go in and you could put in and substitute in and figure out where everything goes. But you've got 6 different categories in which it should possibly fit. You can always do a t-table, or as you get familiar with these, you'll just be able to do it on your own. Okay, so that is if we have an x squared in the denominator. Okay, so we can come back up to our problems here, or our notes, I should say, not problems. But if we have y equals 1 over x squared something, okay, then our asymptotes, okay, are going to be, let's see, let's do minus k. So our asymptotes would be x equals plus or minus the square root of, in this case, k, right? Because we would have to square that. And again, our other asymptote is y equals 0. Okay? So hopefully that makes sense to you on that. Okay. We'll try some more.